Hello, and welcome to another virtual episode of NASA Science Live. I'm Amber Strawn, an astrophysicist at NASA. On today's episode, we're going to be making history with a very special announcement about an upcoming mission at NASA, so don't go anywhere. Today, we're going to talk about one of my favorite topics, unsolved mysteries of our universe. In the mid-2020s, NASA will launch WFIRST, a space telescope that will advance our understanding of dark energy, an enigma that has puzzled astronomers like myself for decades. Dark energy is a form of energy that makes up about 2/3 of the entire universe, and yet we don't know much about it at all. The WFIRST mission will also search for planets beyond our solar system, known as exoplanets, and will measure light from 1 billion galaxies over the course of the mission lifetime. Sounds incredible, right? It will be. Let's take a deeper dive into the WFIRST mission to learn a little more.
The universe. For all we have learned about it, we have only just begun to reveal its secrets. What are dark matter and dark energy? How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? WFIRST, the Wide Field Infrared Survey Telescope, will help answer these fundamental questions. WFIRST is similar to Hubble, but with the benefit of 30 years of technological improvement. Each image from its wide field instrument will have the depth and clarity of Hubble's best, but capture a sky area 100 times larger. WFIRST will take the lead in exploring dark energy and dark matter. We only know they exist by their effects on observable matter, yet these two mysterious components make up 95% of the universe. WFIRST's powerful 2.4-meter mirror and enormous field of view will also help us in the search for planets beyond our solar system, or exoplanets. It will watch for gravitational microlensing events, caused when a planet and its host star pass in front of a background star. Such events are rare, so catching them requires watching large swaths of the sky. To deepen its study of exoplanets, WFIRST will house a beyond state-of-the-art coronagraph that will directly image and analyze Neptune-sized planets in orbits slightly larger than Earth's, a dramatic improvement over current capabilities. WFIRST will help us answer many of the biggest cosmic questions. Its wide field view and coronagraph will complement missions like NASA's James Webb Space Telescope and Transiting Exoplanet Survey Satellite, TESS. WFIRST will be an indispensable part of space science during the next decade and beyond.
What an incredible mission this is going to be. I'm so excited to be here talking about this science today. And joining me now is the Associate Administrator for Science at NASA, Thomas Zurbuchen. How are you doing, Thomas?
I'm doing great, Amber. How are you?
Doing good, doing good. I understand you have a big announcement to share with us today. Do you want to go ahead and tell us what that is?
Absolutely. I'm so excited that we're renaming the WFIRST mission. We knew all along that we wanted to name it, in a way we had before, after a person who's really important for astronomy, very influential for NASA. And I think we found just the right person again. And frankly, the person we want to rename this after is a person who had huge influence in all of astronomy and space. It's a person who imagined the influence of space astronomy before others even thought that that's possible. It's a person who imagined the Hubble Space Telescope before it had a name, before it was even a concept, and was there all along from the idea to making that telescope a reality. When faced with challenges, this person persevered, pushed beyond through these challenges, and became a leader of the entire astrophysics community. In a time when women were actively discouraged from careers of science and astronomy and mathematics and so forth, she became an astronomer. And she became the highest ranking woman in NASA during a time where there were very few that made it up the ladder. She continued to be an advocate for Hubble even after her retirement. And that's why today I'm so excited that we can rename this telescope for it to become the Nancy Grace Roman Space Telescope.
It's hard to decide how history will view my accomplishments. People generally aren't terribly interested in what gets things started. And so I'm not sure they're going to have much of an idea of my role.
Nancy Grace Roman served as the first chief of astronomy in NASA's Office of Space Science, the first woman to hold an executive position within the agency. She was instrumental in the early planning of NASA's first great space observatory, the Hubble Space Telescope, earning her the nickname the Mother of Hubble. To honor her, NASA has given her name to one of its most powerful upcoming space observatories. WFIRST, the Wide Field Infrared Survey Telescope, is now the Nancy Grace Roman Space Telescope. Nancy Grace was born in 1925 and developed an interest in astronomy at an early age.
I just was fascinated. Between 5th and 6th grade, I organized my friends into an astronomy club to study the constellations. I certainly did not receive any encouragement. I was told from the beginning that women could not be scientists.
Nancy Grace persevered and graduated from the University of Chicago in 1949 with a doctorate in astronomy, despite continuing to encounter discrimination.
My thesis professor, there was a period in which he went for 6 months without speaking to me, even when I said hello to him in the hall. He didn't want to have anything to do with me.
After several years of research, NASA came calling.
I started in NASA in 1959. I was 6 months old. Being the first executive woman at NASA turned out not to be terribly eventful. I was accepted very readily as a scientist in my job.
During her 21 years at NASA, Dr. Roman was involved in the development and launch of many space-based observatories, which studied the sun, deep space, and the Earth's atmosphere. Her most enduring legacy at NASA was the planning of Hubble and its science program. She did much of the early advocacy and established the program's structure, which laid the foundation for other large NASA missions that followed, and helped convince the astronomical community to support astronomy from space. After retiring from NASA, Dr. Roman stayed involved in the space community and received numerous awards for her pioneering work. Over her career, she inspired generations of young astronomers. Now, with the Nancy Grace Roman Space Telescope, her legacy can continue to inspire generations more.
Dr. Roman really deserves to be permanently associated with this amazing mission that she really helped enable in a direct fashion. And I'm so delighted to have that name there as a lasting legacy to this amazing person that I have learned so much about. And especially what that means to me is that really Nancy Grace Roman deserves a place in the heavens she studied and opened for so many. How do you feel about it, Amber?
Yeah, I mean, it's just incredible, and she's so deserving to have this telescope named after her. You know, I was in the 5th grade when Hubble launched, and I remember that, being a kid and seeing the Hubble Space Telescope launch, and it was one of those things that really solidified in me my desire to be an astronomer. So will you tell us a little bit, Thomas, about how this decision was made for this telescope to be named after Dr. Roman?
So you should know, if you're in a job like mine, there's a lot of people with a lot of ideas that come to you. And that does not surprise you. And one of the things I noticed really quickly is that whenever we talked about WFIRST, there was one name that always popped up, and it is Nancy Grace Roman. Of course, I started to learn about this and actually did work. I actually, learned about her passing away, learned the great articles that were written by so many. And I learned about her legacy, including the first space telescope series, the orbital astronomical observatories and orbital solar observatories in the 60s and 70s. And kind of the more I heard and learned about this, the more excited I got about naming it to that. And ultimately, of course, this is a decision of the administrator was just as enthusiastic once we talked about the options here.
Yeah, it's just so exciting. I think she's just a perfect namesake for this telescope. Can you talk a little bit about some of her accomplishments that sort of led to this decision?
One of the coolest things about her is that she joined the agency like when the agency was 6 months old, right? So it's really one of the pioneers from the beginning there, and really she established the most important kind of policies and organizations that have gotten us to where we are in space astronomy. And so for me, it's just for that reason, that vision, that foresight, of course, with some of the others on the outside, but with that leadership on the inside of the agency, that really makes her, I think, the only name that is appropriate for this large space telescope that we're building now, the Nancy Grace Roman Space Telescope. But how do you think about it, Amber?
Yeah, I mean, it's seeing women like this who are trailblazers in astronomy be honored in this way it's really encouraging. And personally, I've looked up to women like Nancy Grace Roman and some of the other pioneers in astronomy over the years. And so it makes me feel great to know that this awesome space telescope has been named after her. So thank you so much for joining us, Thomas, to make this exciting announcement.
Thanks to you.
What an incredible woman. Raised in a time when women were discouraged from pursuing science, she not only succeeded in establishing herself as a scientific leader, but she's left a legacy for the astronomers of today and tomorrow. I'm joined now by two more experts, Julie McHenry, NASA Roman Deputy Project Scientist, and Elisa Quintana, NASA Roman Deputy Scientist for Communications. Elisa and Julie, as members of the team, what does it mean to you that this mission is being named after Nancy Grace Roman?
I find it tremendously exciting that the observatory is being renamed for two reasons. Firstly, I think it's a mark of how far the mission has come that we are being renamed. It says something about how far the development of the mission, that we're a real thing, that stuff is actually really being built. But more importantly than that, and from a personal perspective, I'm really excited that the mission is being renamed after Nancy Grace Roman. She's somebody I really admired, and it makes me excited and proud to be associated with a mission that's named after her, and that this is something that I'm going to enjoy day after day after day as the mission continues.
Great. Elisa, what are your thoughts?
Well, I have so much admiration for Nancy Grace Roman. She believed that she could be an astronomer during a time when there were so many barriers to women pursuing careers in science. She then went on to become a leader and a visionary at NASA, really working to facilitate, the development of astronomy missions. What she really believed in was investing in missions that would be useful for, future generations. And so I'm really honored to be part of the Roman Space Telescope mission, and I'm really pleased that this mission is being named after her.
I have a few more questions for you, Julie and Elisa. First, why is it appropriate to name WFIRST after Nancy Grace Roman?
Nancy Grace Roman was the driving force behind Hubble. She was really one of the people who made that mission come into being. And one of the things I really admire about Nancy Grace Roman is that she had the scientific skills and the technical skills and the management skills and the understanding and knowledge of how the system worked, so that she was able to bring all of these things together to make Hubble happen. She was very insightful, and I think it's very important to recognize that large NASA missions take more than just being a good scientist, or take more than just being a good engineer. That you have to have people like Nancy Grace Roman who really understood the details of all of those things and could bring them together.
Totally agree. Elisa, could you tell us your thoughts?
Sure. So I think it's really cool that she joined NASA in 1959. So this is very soon after NASA was created. She was the first chief of astronomy, the first women executive at NASA. And she really advocated, putting astronomy instruments in space. And it's because of her and people like her that, we have missions like WFIRST. And so, NASA doesn't just build missions for science that we know about today. You really have to be a visionary like Nancy Grace Roman to develop instruments that are going to let us explore and, really try to understand the unknown mysteries in our universe. And WFIRST is going to be really exciting. We anticipate many, many new discoveries, and all of this is because of the foundation that Nancy Grace Roman put down.
Absolutely, couldn't agree more. So could you both tell us a little bit more about the mission? What are some of the science goals of the Nancy Grace Roman Space Telescope?
So to tell you a little bit about the science goals of the Roman Space Telescope, I need to tell you first a little bit about how about the observatory itself. The mirror on the Roman Space Telescope is the same size as the mirror on the Hubble Space Telescope. But the main science instrument, the wide field instrument, has a field of view 100 times larger. That means that at any instant when the Roman Observatory is viewing the universe, it will see a swath of the sky that is 100 times larger. The Roman Space Telescope also observes more efficiently, can move from one place to the other more quickly. It spends a larger fraction of its time looking at the sky. So with this, we're going to be able to view the sky in a new way. We will be surveying the sky, looking across large areas, or looking at places where we don't know when to expect something, but we're simply monitoring it. And this is very different to pointing at a specific object with a telescope that has a much smaller part of the sky that it views at any instant. So with the Roman Space Telescope, we're going to see hundreds of millions of galaxies. And we're going to measure precisely the distance and position of each of those galaxies. For a fraction of them, we're going to very precisely measure the shape of those galaxies, and we can use this information to study the structure and evolution of the universe. We can also explore our sky in other ways as well. We plan to pick a region of the sky and go back time and time and time again. And in this region of the sky, where there are hundreds of thousands of galaxies, if a star in any of those galaxies goes supernova, that means it explodes at the end of its life, WFIRST will be able to find that. And we will have tens of thousands of supernova discovered with WFIRST by the end of the mission. And we can use those to study those exploding stars. We can use the information from that as a different way to understand the structure and evolution of the universe. And then finally, when you explore the universe in a way that you're just looking to see what's there rather than looking at a particular spot, you're no longer looking under the lamppost. You're going to be able to find the things that you didn't expect. So I'm confident that the most exciting science return from the Roman Space Telescope will be things that we didn't expect to find.
That's so great. And for me, that's one of the most exciting things about any telescope that NASA puts into space is those surprises that they're out there in the universe waiting for us to find them. Elisa, what are your thoughts on the exciting science that this new mission will discover?
Sure. So in addition to all of the amazing discoveries, one of the other goals of WFIRST is to discover and explore exoplanets. So these are planets orbiting stars outside of our solar system. We currently know of over 4,000 planets outside of our solar system, but most of these were discovered with a technique called the transit technique. So you may be familiar with the Kepler and TESS missions. So WFIRST will use a different technique called microlensing. It uses a light bending phenomena to discover planets on much wider orbits than we previously know of. And so these are orbits comparable to Venus's out to Pluto, these planets on these colder orbits. So what we learned with WFIRST microlensing combined with Kepler and TESS is really going to allow us to complete the census of planetary system architectures. This is going to allow us to understand, questions like how does our solar system fit, in the grand picture of planet formation. WFIRST will also have a coronagraph technology demo instrument. This is an instrument that's going to directly image exoplanets by blocking out a star's light. So you can see much fainter planets orbiting these. And we'll also be able to image dusty disks, which form the building blocks of planets. And so it's really going to allow us to explore this whole new discovery space of planets and how they form. And also push the limits with technology. What else can we send up into space?
That's so exciting. You know, my own personal research is about galaxies. I'm interested in how galaxies change over billions of years. But I think some of the exoplanet science that the Roman Space Telescope will do is going to be some of the most exciting stuff that we learn. So we've heard a lot today about the impact that Nancy Grace Roman has had on the field of astronomy in general. How will this encourage future generations of girls?
You know, it's fantastic that this observatory is being named after Nancy Grace Roman. She deserves it. Her contributions, not just to developing the Hubble Space Telescope, but in developing astronomy in the early days of NASA, all across the various different astronomical observatories that NASA launched, is really truly extraordinary. I'm delighted that this observatory has been chosen to be named after Nancy Grace Roman. But what it's also really nice that she happens to be a woman. I think that is important for young girls to see what's possible and to see somebody who is more like them being acknowledged in this way, which will encourage people to look more closely at what she did achieve through her life. And I think we can all derive some inspiration from that.
Absolutely agree. Elisa, what are your thoughts?
Nancy Grace Roman accomplished so much in her life. I really respect how much she was able to accomplish, during this time when there really weren't very many role models of, women in science or in space development. Nowadays, almost everyone knows about the Hubble Space Telescope. It's enabled so much science over the past few decades and, provides so many amazing discoveries. And so coming up and, soon and over the next few decades, we're going to have the same experience with the Roman Space Telescope. People are going to know her name, read all about her background and her perseverance and her strength. And I think that is just in itself really inspiring, looking to see how much she accomplished and really inspiring everyone.
It's great. I couldn't agree more. Well, that's all the time we have for our show today. Elisa, thank you so much for joining us.
Thank you so much for having me.
And Julie, thank you as well for joining us today.
Thank you. It was a pleasure.
We're so excited for what the Nancy Grace Roman Space Telescope will reveal about our universe and to honor the extraordinary and pioneering woman that this telescope is now named after. For more information about the Roman Space Telescope, you can visit nasa.gov/Roman. Thanks for watching.